So far we have seen what an operating systems is. Operating systems is nothing but a program which is going to act as a resource manager. Okay. Now this operating systems program will always be present inside the RAM, which means whenever we switch on the computer, this operating systems program will be loaded inside the RAM. Okay, this is the code, right? This code will be loaded inside the RAM, and this program will be in the RAM forever. Okay, will always be present inside the RAM. Now this code is what we are placing it here, right? This code will always be present inside the RAM, and we say this set of addresses. See, our RAM will be full of addresses, right? And these set of addresses where the operating systems program is placed is also called as OS code space, right? It is also called as OS space. Whereas the remaining space is used for placing our programs. Our programs means application programs. The programs which we write are the programs which belong to a particular software like Photoshop, Word and all this, okay? All these programs will be actually placed within this space, and we say this space as user space, okay? We also say this as user space, where we place a lot of programs. For example, P1, P2, any programs, okay, which we execute will be placed within this space. Fine. Now so far we have seen how CPU, RAM and hard disk work together. How? For example, initially our source program will be given to a compiler and it will be converted to machine code. Once it is converted into a machine code, it will always be placed inside the hard disk. Okay. Now at some point in time, this program will be loaded into the RAM, and once within the user space, and once it is loaded into the RAM, this program at some point in time will be taken by the CPU line by line and executed. Okay, this is how a program actually is being executed. Fine. Now once this execution of this program is done by the CPU, right, at some point the program is actually executed by taking line by line by the CPU, and at some point in time the execution of this program will get done, right? Once it is done, this program will be completely removed from the RAM. Okay, no more all information about the program which is maintained inside the RAM will be actually completely removed, which means the space will be free. Why? Because some other programs can accommodate that space, right? That's the reason we do that. Fine. Now let's see how IO devices means keyboard, monitor, mouse and all these devices, right? How these devices work along with the CPU, communicate along with the CPU. That's what we are going to see, right? See, any IO device will have a buffer associated with it. For example, our monitor will have a buffer. Buffer means nothing but memory or register, okay? This space. And also keyboard, printer, you can take any device. Every device will have a buffer associated with it. Now, why this buffer is actually helpful? Now, just to understand that, let's see how a calculator application works in our computer. Okay, we have a calculator software. Okay, a software. Now this software will be in exe format, right? Executable code. We have already seen it. Machine code is nothing but executable code. Both are same. Now using this software, I am going to add two numbers, say 2 plus 3, and then I wanted to see the result equal to 5 in my monitor. Okay, see 2 and 3 I am going to give it through keyboard. Okay, a mouse or keyboard, anything is fine, but let's assume for time being both 2 and 3 are given to the computer through the keyboard. And once the result is computed, this result 5 has to be displayed in the monitor. Okay, this is what we are going to do. First, we will be opening this. First of all, what we will be doing is we will be opening this calculator app, right? Now, for that, in case if the calculator app is already present inside the RAM, it is fine. If the software is not present inside, this software is nothing but a program, right? Calculator program. In case if the program is already not present inside the RAM, it will be fetched from the hard disk and then it will be placed inside the RAM. Okay, let us assume the calculator app is now present inside the RAM. Fine. Now whenever I enter 2 in the keyboard, the key 2 in the keyboard, 2's binary format. 2's binary format is nothing but 0 1 0, right? This will be placed in, this will come into the buffer. Why this is coming as a binary format? Because computers can understand only in binary format, right? That's the reason the 0 1 0 will get into the buffer. Similarly, now this, from this buffer, this will be moved into the RAM. Okay, 0 1 0. 0 1 0 is nothing but 2, right, in binary. Similarly, whenever I type 3 in keyboard, 0 1 1 will override this in the buffer, and the 0 1 1 will also be moved inside the RAM. Okay, fine. Now once this is moved into the RAM, the CPU will take both the 0 1 0 and 0 1 1 inside its register. See, CPU will also be having a buffer or register. Okay, generally how CPU will perform its operation is, it will take the operands. Here operands means 2 and 3 are operands, right? These operands will be taken into the register 0 1 0 0 1 1. Not this operation, any operation will be done in this way. Okay, all the operands will be fetched into the register and the operation will be done by the CPU. Here the operation is nothing but addition. It will be done by the CPU and the result will be overwritten in one of the registers, any register. It really depends on the implementation. Okay, one of these two registers, the result will be placed. 2 plus 3 is nothing but 5 and 5's binary format is 101. This will be overwritten over this. Now who actually does this addition? It is done by the CPU. How? Because CPU will be having two parts, okay, control unit and arithmetic and logic unit. Let's see about control unit a bit later. It's not important for this course actually. Now coming to arithmetic logic unit, will do all the mathematical operations which we do in our computer. It can be addition, subtraction, logarithm, multiplication, division, any mathematical operation you take, it can be done by our arithmetic and logic unit using hardware circuits. Okay, using this, the result 101 has been computed and this will again be placed inside the RAM. Okay, this 101 will be placed inside the RAM. Fine. Now this has to be displayed in the monitor, right? We want to see this in monitor, the result. Now what will be done is, this 101, which is the result, will be placed in the monitor's buffer. 101, as a result of which we are able to see the result in our computer screen. Okay, this is how this is being done. Okay, let's take one more example. Okay, see, I'm explaining all this to understand one thing. Okay, I'll explain it later. Now let's take one more example. I'm taking some Word document has been already created and it has been saved. Okay, if it is saved, it has to be present inside the hard disk, right? Let us assume there is a Word document which is present inside the hard disk. The name of the document is say A. Okay, this is the name of the document. Now I wanted to edit this document, which means I want to add some more letters into the document and then I might have to save the document. Okay, so what I should be doing is, first this document will be moved from hard disk to RAM. Why? Because CPU cannot access the hard disk directly. Now to edit that, this has to be moved into the RAM. Fine. This document is moved into the RAM. Okay, which means something is moved from hard disk to RAM, and this document, first of all, this MS Word is a program and that program will also be loaded into the RAM. Okay, I'm not showing it here, but you understand it. The MS Word is actually a software, so that will have a back program and that program will also be placed inside the RAM. Fine. And that program will be executed by the CPU. That is fine. Now this is nothing but data. This data has been loaded into the RAM and then the editing will be done, which means in case if I wanted to add some text to the Word document, that will be done through the keyboard, just like how we saw. The words which we type will be placed in the buffer in some binary format. See, any letter can be represented in binary form, right? Those words will be placed in the buffer and then it will be moved into the RAM. okay, into that exact document. Once this is done, this Word document, now we need to save this document permanently, right? The only way to do this is to move the document from RAM to hard disk back, right? So we have made the changes to the document. So what we have done is, this program, first of all, we loaded our program, which is nothing but MS Word program. This program has been loaded into the RAM, and also we loaded the data from hard disk to RAM. Then we made some changes to the document, and then we again placed the document into the hard disk. Okay, so hard disk, we can either read something from the hard disk, as well as we can write something into the hard disk. Okay, so hard disk can act as an input device, as well as it can act as an output device. Okay, hard disk can act as an input device as well as it can act as an output device. Whereas in case if you take keyboard or monitor, keyboard can always act as an input device. Why? Because we can only give input to the computer through the keyboard. Similarly, monitor is an output device. Why? Because through the monitor, we as a user will be able to receive the outputs, but we will not be able to give the input through the monitor, right? So monitor is an output device. Similarly, hard disk is an input, can act as an input device as well as it can act as an output device. Okay. So one more important point is, all this I have explained for explaining only one thing, to say that a program can undergo something called as IO. Okay. IO is nothing but, for example, this MS Word, this calculator program or the MS Word program in both our examples are placed inside the RAM, and they are waiting for some time to read the data from one of the IO devices, input device or output device or IO device. See, IO device is fine. Okay, a hard disk, keyboard, monitor, all this we can say this as those as IO devices. Okay, which means our program is actually waiting for IO for some time. Okay, that is what we mean by IO event. So once a program has been moved from hard disk to RAM, what are all the things this program can undergo? Okay, either this program will be in the RAM, this program will be in the RAM and it will be executed by the CPU by taking line by line. Such things we say that as execution. Okay, execution. Or this program which is in RAM undergone IO. Okay, such thing we say that as IO event. Another possibility is that this program is neither performing execution, this program is neither executed nor this program is waiting for IO event. In that case, this program is actually waiting for the CPU to execute, or it is waiting for some IO event, right? In that case, we say that this program is actually waiting for some event to happen. Okay, so in simple terms I can say that, see, one point I want to tell is, there is something called as turnaround time. Okay, okay, turnaround time equal to, first let me write the formula and then I will explain it. Okay, turnaround time equal to waiting time plus burst time plus IO time. Okay, so every program at some point in time will be loaded into the RAM. Okay, let us assume that there is a program named as P1. Okay, this program is let us assume this program has been loaded from hard disk into RAM at 1 AM. Okay, at say 1 AM, and let us assume that this program has completed execution at 3 AM. Okay, this program has completed execution at 3 AM, and I have already told you that once the program has completed its execution, the program will be completely removed from the RAM. Okay, this program will be completely removed from the RAM. Now this duration of time from 1 a.m. to 3 a.m. is also called as turnaround time. Okay. Now during this turnaround time, what are all the things this program should have undergone? Which means during this time from 1 a.m. to 3 a.m. this program should have either waited, which means it should have waited for some event to happen, or this program should have been executed by the CPU. See, execution time and burst time both are same. Okay, we can also say this execution time as burst time, both are same. Okay, or this program should have undergone IO. Okay, so this turnaround time is a combination of waiting time plus burst time plus IO time. See, actually we can't say which one among waiting or burst or IO will happen in which order. Okay, in which order this will happen. A program, once it is loaded from hard disk to RAM, it can undergo either waiting time for some duration of time, or it should have been executed for some duration of time, or this program should have been undergoing IO for some duration of time. In what order this happens is really dependent on the program. For some programs, for some programs the ordering will be different from one program to another. Okay, that's what I wanted to tell you. See, in case if you didn't understand this formula, you don't really worry, because we are going to see a lot of problems coming to this concept. Okay, we are going to see something called as scheduling algorithms. Okay, in that we will be seeing all this concept. Okay, fine.